Hey guys, so the the app I'm using to record this has like a time limit, so I'm gonna have to cut this into two videos. But I promise I'm almost done. But I was gonna do just I wasn't gonna make it this long, but it's kind of hard to explain this without explaining all the other stuff in the previous video first. Um, so anyway, what I was talking about, I think when it cut me off was this formula right here. So it's the uncertainty principle. Basically, I already explained it. Can't know the position and the momentum with too much certainty at the same time. So yeah, this guy Heisenberg got a Nobel Peace Prize. So that's pretty cool. Basically, what led to what I'm about to talk about, which is matrix mechanics, is the old classical formula, um, which describes the position and momentum of a particle, was right for the most part, and there's a reason it's classical, which classical mechanics basically just describes like old physics, like before we knew about like radiation and all that stuff. So basically, I failed to recognize the absorption of radiation of particles. So like electrons specifically, if they're moving around other electrons, they absorb radiation from each other, and so that's what led to go to the next slide. The Heisenberg Matrix. So it's based on harmonic oscillators, which is I kind of mentioned earlier. The point particle moving or like some kind of mass moving on a spring. So that would be a harmonic oscillator because it's oscillating back and forth. Um, so these two vectors describe the position as the top one. So it has x. It's the position of a particle at any given time based on initial conditions. So this is a really basic example. I actually found this on Wikipedia. I cited it. Don't worry, but um, yeah, basically, so yeah, it's just the position at some time, and this matrix describes the momentum at some time based on initial conditions. So you have those two matrices independent of each other, but there's a such thing as a Heisenberg group, which is the product of two Heisenberg matrices. So of like the position and the momentum, and um, yeah, it's this is really advanced stuff. So I'm not exactly sure what the product is of these two matrices. Um, like if you have a position matrix and a momentum matrix multiplied by each other, I'm not exactly sure what that yields. But yeah, we have the so you have the identity matrix here, and then you have these three quantities right here, A, B, and C, and then A, B, and C prime. So basically, this first matrix is um okay, actually I do, yeah, I do know. So this first matrix basically is A, B, and C would be three quantities that you want to know about. So it would be either like the position, the momentum, and the energy, for example. There could be other things, but those are the most three common things that you want to know about for a particle. And then A, B, and C prime would be those same three quantities that you want to know about after some event has happened to the particle. So, for example, like you have an electron in a vacuum. That's how they do these experiments. They put like an electron or some kind of point particle in a vacuum, and then you accelerate it. So you have the electron initially at rest, and you have the rest position. You have wherever it is, the position of it. It has no momentum because it's not moving. And well, it would be moving a little bit. It would be vibrating, so it would have some momentum, but it wouldn't be nearly as much momentum as later on, and some amount of energy. And then after you accelerate it, the energy obviously would go way up, and the momentum would go way up because the velocity would increase after you accelerated it. Um, and then yeah, so that's basically the Heisenberg group. Basically describes what happens to a particle before and after it experiences some kind of event. And this is just a great example of matrix algebra. So from linear algebra, matrix algebra being used in a context other than just linear algebra. So it's an actual like context that it's used in. Um, so yeah, I thought this was pretty cool. Um, Here's the list of items that are kind of used in um, physics a lot that we talked about in um, matrix algebra or in linear algebra. Um, and here are my works cited. So, oh yeah, so specifically, I would like to thank Dr. Hester, Dr. Coffey, and Dr. McGahee from the physics department because I've had a lot of classes with them, and they just kind of have all this understanding that I have of physics is from them. And also, of course, Dr. Klima for teaching me linear algebra. And now I have this connection between these two fields, which hopefully will um, help me in the future, whatever endeavors I get into. So, yeah, thanks for listening, everybody. Um, Hope you learned something from this. And if you haven't, take some physics classes because physics is the best thing in the world to learn about. All right, have a good one.